Hello, I'm Rob Aubie, Technical Specialist for Sony Media Software. Welcome to the UMD Composer Authoring Evaluation DVD. During the next several minutes, I'll introduce you to the basics of the UMD Composer authoring environment. With what you learn in this introduction, you'll be able to effectively evaluate the benefits that the UMD Composer software brings to the process of creating UMD discs. Discs that you can distribute worldwide to the owners of the PSP, the PlayStation Portable device. I'll answer many common questions that may have come up for you since the introduction of the software in the fall of 2005. We'll cover all aspects of the UMD Composer authoring environment, from gathering and processing your media assets for the most effective encoding, to developing the scripting needed to produce the best menu and navigation elements. I'll show you how to compile your scripting files, and finally how to produce the image files you need to replicate the UMD discs themselves. I'll also explain the comprehensive support plan for the various UMD Composer packages. And finally, I'll introduce the additional features that we've included on the DVD-ROM. This DVD contains a wealth of information on the UMD Composer software. As I already mentioned, you'll get a good overview of the UMD authoring process to help you evaluate the product. You can also use your computer's DVD-ROM drive to open the documents on the disk. You can view and you can print them. I'll use some of these documents in this demonstration, and you can use them later as reference and sample material when you and your staff begin to author your own UMD discs. Sony Media Software offers a comprehensive support plan for the UMD Composer software. With each agreement, your company receives direct contact with technical support experts and the developers of the application. An exclusive and secure developer forum dedicates itself to the UMD-Video format, and you can take advantage of that support 24 hours a day, 7 days a week.
The UMD Composer software contains 3 software packages, each with a series of applications that break the product down into its 3 main elements. First, the Stream Composer package includes all of the applications needed to encode and multiplex the materials that you want replicated. Second, the Video Interactive System package includes all of the applications and example code you'll use to create the interactive menu and button navigation elements for the look and feel of the UMD disc. Lastly, you'll use the Image Generator package to build the image files that create the testing DVD. You'll deliver that same set of files via WAMnet to the replication facility for master creation and UMD disc production. These software packages work in the Windows environment. You need a stable PC workstation for optimized performance. Sony Media Software offers several well-tested recommendations on the hardware that will best suit your needs during production. The recommended system requirements break down into 2 areas: the front-end PC and the distributed server environment. The front-end PC consists of a modern workstation running Windows XP with Service Pack 2 and .NET 1.1 installed. You'll need a DirectX compatible video card capable of direct draw and a monitor that supports 1600 by 1200 resolution. You will also need at least 1 GB of ECC DDR memory, a gigabit Ethernet connection, and if desired, an SDI graphics board for external viewing of the encoded material. The distributed server environment complements the front-end PC workstation and allows you to distribute the encoding of the material across multiple servers. This helps you decrease the render times of the encoding process. A NAS server with multiple high-capacity HSHDD drives is optimal, as well as a server RAID controller. You can use up to 50 encoding servers per Stream Composer license, and each should have the same ECC DDR RAM as the NAS server. They must run Windows Server 2003. You'll also need a gigabit Ethernet switch. As you begin to organize your projects for UMD production, you will need to gather all of your assets in the correct formats and file types as required by the UMD Composer packages. All video assets must be converted into the standard Windows-compatible AVI files. The frame rate for these files can be 23.97p, 29.97p, or 59.94i NTSC. The frame size needs to be 720 by 480, 720 by 486, 352 by 480, or 352 by 240. You must use the YUY2, RGB24, HUF YUV, or DV AVI Type 1 or 2 codecs. You must create subtitles as uncompressed TIFF files at 16-bit color with a frame size of 720 by 480. You'll use the SST or NAV formats to write the navigation file for subtitles. And finally, you must save still images as .bmp files at 24-bit color. When importing video content into Stream Composer as an AVI file, it is recommended that you first convert the original video format to the accepted AVI standard. For example, you may have a digital Betacam tape with a 2.3 pull-down NTSC version of a film. To convert this footage, we recommend our latest version of Vegas, the professional nonlinear video editing application from Sony Media Software. Since most original video and audio content is not natively in the AVI format, you need to capture and convert your original content into this format. Sony Vegas software makes that process easy. Vegas supports Blackmagic Decklink cards, allowing program ingest from any SD or HD SDI mastering deck. The first of the three packages in the UMD Composer software, the Stream Composer package, generates the encoded materials and other files that make up the content and heart of your UMD project. In the most basic sense, the Stream Composer takes your video and audio content and formats it correctly to play from the UMD disk on the PSP player. The Stream Composer package consists of three applications: the Stream Composer, the Stream Viewer, and the Playlist Composer. To begin, let's take a look at the Stream Composer interface. The Stream Composer encodes the audio, video, and subtitles. It does the multiplexing and has support for multipass encoding and bit reallocation. As you look at the interface, you see a basic video timeline with appropriate window panes that reveal project information and the details of the project's main assets. In Stream Composer, you first name and save the project in your chosen location. To do this, you'll modify the environment settings under the Settings menu and then click on New to open the Create New Setting window, and type in a clip name and project name. Then select Next. You are asked to set up the screen details. For this demo, we will choose one video stream and one audio stream and one subtitle stream. We will keep the starting time code at 0 hours and keep it drop frame. Next, use the four main source selection menus on the toolbar to import the assets you want to encode. You see one menu each for video, audio, subtitles, and stills, and your project might use any or all of these types of assets. When importing video and audio, you must follow the material type specifications. For video, start with a 720 by 480 NTSC AVI file at either 2397 or 2997 frames per second with the HUF YUV or DV AVI codec. For audio, use either an AVI file or a WAV file at 48 kHz and 16 bits. To import subtitles, you need the coded reference file that will associate with the still image subtitle file. This file must conform to the .sst standard or .nav standard. The manuals detail alternative settings and versions that you can use in addition to these basic requirements. To import a video and audio AVI file into Stream Composer, click the Video Source button. This opens the Video Source dialog box. On the Input File tab, click the Open button and navigate to the AVI file you want to import. I'll choose the Bikers AVI file. This loads the clip into the first stream file location. An error message would alert you if your AVI does not conform to the required specifications. To import the audio portion of the AVI file along with the video, check the Insert Audio and Video Data Simultaneously box in the About Operations area of the Environment Setting dialog box. Click OK from the Video Source box to load the two chosen files to the appropriate timeline locations. With your video and audio streams now loaded to the timeline, you can add other video and audio files onto subsequent streams and any subtitling streams that you wish to have encoded during the encode process. To add additional files, follow the same procedure. With your assets in the Stream Composer timeline, you now need to adjust the settings for the encode process. Click the Video Encode Settings button to open the Video Encode Settings dialog box. Here you can apply several settings to control the upcoming encode process. Note specifically the average bitrate, max bitrate, and encode mode options. With these options, you can strike a balance between the file size of the finished encoded material and the quality of the encode. These also affect the length of the encode session. The Stream Composer user manual contains details for each of these selections as well as the options available in the Advanced section. In most cases, the default settings work perfectly, but you may need to adjust these settings depending on your project. In the Audio Encode Setting dialog box, you can adjust the bitrate of your audio encodes to again balance between encode quality and file size. Click the Subtitle Source Selection button to open the Subtitle Source Selection dialog box. Here you can assign the appropriate SST file for the subtitle script that will accompany the video and audio streams. Under the Attribute tab, select the appropriate aspect ratio and language. The Composer manuals give detailed descriptions of all specifications associated with creating compatible SST files and the associated TIFF image files. To set the encode range and add chapter mark settings, click and drag the timeline indicators to the appropriate locations. Or if you have an Excel spreadsheet that contains all your SMPTE timecode markers, you can import that file to create chapter marks. You can find an example spreadsheet in the resource folder located in the DVD-ROM portion of this DVD. You can also adjust filter settings. Click the Filter Settings buttons to open the Filter Settings dialog box. The size setting allows you to crop down or add black to the frame size of the AVI file so that it meets the required 720 by 480 frame size. Set the interlace setting and adjust the inverse telecine indicators as appropriate for the format of the original content. You can also apply low-pass filter, noise reduction, and scene changes here. Now you're ready to start the encode and multiplex that creates the MPEG-4 AVC file for production. Here the need for speed is ever present. If you have the hardware available, you can set up a distributed encoding farm to utilize the processing power of several computers. This helps you more efficiently encode a lengthy video stream instead of relying solely on the main front-end PC to do the job. For example, to encode a full project of video, audio, and subtitles, you should expect to build a render farm with 16 to 20 servers to create a 1-to-1 encode ratio. In a network encode setup, the front-end PC runs the Stream Composer software and distributes the encoding task to a series of servers shared across the high-speed network. When you purchase the UMD Composer software, you have the right to distribute the encoding of streams to up to 50 encoding nodes per license. In the DVD-ROM section of this DVD, you'll find helpful documentation that details the distributed encoding setup requirements and options. To initiate your encode and multiplexing of the streams, click the Run button and choose either Encode, Multiplex, or Encode plus Multiplex. Most commonly, you'll choose the third option, Encode plus Multiplex, which opens the main encode dialog window and begins the process. If you're encoding multiple projects at one time, Stream Composer now allows you to separate the encoding and multiplexing to individual PCs for increased efficiency. If you need to, you can click the Cancel button to terminate the encode. When the encoding and multiplexing process finishes, you can use the Stream Viewer application to view the completed files. After opening Stream Viewer, use the File menu at the top of the Stream Viewer window to navigate through your folder structure. Find the location you originally designated in the Stream Composer's environment settings. Once you locate your folder, the Browse dialog displays only the compatible file, depending on which option you selected from the File Open dialog. Now that each file type has been loaded into the Stream Viewer, use the VCR type controls to view the encoded files. You can also view the streams on an external monitor via an SDI link to a graphics card. For details, please see the hardware recommendations on the DVD-ROM portion of this DVD. You'll notice the Stream Composer package contains an additional executable application named Playlist Composer. This application creates a specific file as part of the final image directory for the UMD. After the encoding and multiplexing of the Stream Composer has finished, it exports a clip folder named 00001. The interface of the Playlist Composer uses this folder to generate the playlist.umd file for the image generator package. This application is used to define the playlist that your UMD title will feature. It exports a file named playlist.umd that will become part of the UMD title. Up to 100 playlists can be used, and a playlist consists of one or more play items and a chapter mark list. This list will hold the information about the chapter and event marks that were defined in the Stream Composer for that clip. Each play item is linked to a specific clip. So for example, one playlist can have 3 play items, which means it could be featuring 3 different clips or 3 times the same clip, plus any combination. The last option, using the same clip more than once, can be very useful if you consider that each play item can also use just a part of a clip file and not only the entire clip. For each playlist, it is possible to define the UOP mask, the playlist name, the playlist detail, and the amount of play items. These play items reference a specific clip file, and the in and out frames can be edited. Now let's talk about the most complex and powerful portion of the UMD authoring environment, the Video Interactive System Package, or VIS. The VIS consists of 3 main applications: the script compiler, the video resource compiler, and the interactive system viewer. You can do your work with the VIS in parallel with encoding and multiplexing. We suggest that you install the VIS on a different PC than Stream Composer. First, gather your menu layout and image files together for resource compiling. Compiling your resources will change the formats into an archived resource file. One key component for the VIS provides software emulation of your interactive menus. This emulation consists of a virtual static database and a resource file which contains your assets, such as image files and sound files. The VIS also includes the UMD-Video script or UMD-VS component. The resource compiler of the Video Interactive System compiles the resource XML and UMD-Video script. XML schema describes your menu layout, buttons, audio files, animations, and JavaScript ECMA 262 controls specific methods and functions within the UMD-Video script language. The Video Interactive System consists of executables and batch files that compile your resources, such as your menu's look and feel, button navigation, and submenus. When you compile the resource.xml, static database, and JavaScript ECMA 262 file, you generate the RCO file. The exec.bat batch file then feeds the RCO file into the UMD Video Interactive System viewer. You use the RCO viewer to check the functionality of your XML and your JavaScript ECMA 262 file as it handles the image and audio assets of your menu designs. The UMD Image Generator application consists of 6 executable files: the UMD Generator, UMD Checker, System File Editor, System File Viewer, PSMF Composer, and the AT3 Audio application. The Image Generator creates the files that the replication facility uses to create the UMD disks. The process starts with the System File Editor. This application outputs the param.sfo file that announces your title on the PSP device. It also controls the UMD's parental lock level. Open the System File Editor, then click the Create a New Document icon. Navigate to your System File Template directory. In its default location, you find this file in the Image Creator folder under the Stream Composer Application folder. Choose the appropriate video template for your firmware version. This file has an extension of .sfc. The template loads into the System File Editor application, and you can then modify the 2 values of title name and parental lock level. Once updated, choose Convert from the File menu to convert to the .sfo version. Now save that file with the name param to your project root directory. Next, use the System File Viewer application to check the param.sfo file and verify that you have accurate titling and parental lock levels. Now use the PSMF Composer application to generate the content information file. This file is the animated image icon file you get when you first insert a UMD disk into the PSP player. Open the PSMF Composer.exe located in the Tools folder of the PSMF Composer folder, within the Contents Info folder of the Image Creator directory. This application asks for 3 files that are located in the clip folder titled 00001. Each file was created using the UMD Stream Composer. You would have created an encoded file earlier using the Stream Composer that utilized the PSP movie format for game checkbox during the setup procedures of the clip. The files you are looking for are .mps, sci.xml, and es.lst, which is in the IMF folder within the clip folder. Select all three files. In the output window, click on the Browse button and name the file icon1. Then save. Click the Create button at the bottom of the PSMF Composer window to generate the compiled file. The AT3 application creates audio in the .AT3 format for UMD. The application can both encode and decode audio files. These AT3 files are then used at the root level of the image generator package for inclusion in the generated image files, which will play during the Announce menu on the PSP device when a customer inserts the UMD disc. Sony Computer Entertainment offers a hardware testing tool called the DTP-L1500 to give content developers a way to test the UMD image on an actual PSP player. The testing tool is a standalone DVD-R player tethered to a modified PSP player. When used with a DVD-R that contains the necessary UMD image files created by the image generator package, the DTP-L1500 plays a representation of your project as though it were an actual UMD disc playing on a retail PSP player. If you find bugs in your menu design or problems with functionality, you can update the XML and the JavaScript file by copying them onto a memory stick and inserting it into the testing tool. This allows you to quickly update your code for testing and debugging without having to recreate the DVD-R. The testing tool also has a VGA output, which mirrors the PSP LCD on a secondary monitor. The DTP-L1500 is not sold by Sony Media Software, but you can purchase it from Sony Computer Entertainment. The testing tool document on the DVD-ROM portion of this disc contains contact information for the purchase of the DTP-L1500. Once your files are created by the image generator, and you have sufficiently tested them using the testing tool, it is time to send them to the Sony Encryption Center and off to the Sony DADC replication factory for production. You will have to secure a WAMNet broadband service connection to send your files to the encryption facility. WAMNet contact information is found on the DVD-ROM portion of this DVD. After encryption, your image files will be delivered to the Sony DADC factory that you specify in your encryption service request. Sony DADC will produce your check disks, which are sent back to you for final evaluation before the formal production run is completed.
As you can see, the UMD Composer package gives you a complete set of tools with which you can take your media files all the way to delivery on your customer's PSP. With this brief overview, I hope you can see that the software makes the process easy to manage, while at the same time providing you with the best possible quality. Study the support materials that we've included on the DVD-ROM portion of this disc to learn even more about delivering your movie, audio, and other media files on UMD. Then when you're ready to get started, contact us at Sony Media Software. Thank you for joining me for this overview of the UMD Composer software. We look forward to hearing from you soon so that you can get started delivering your projects to market on the PSP.